So in this experiment, I'm implementing a multi-layer perceptron, which is a type of artificial neural network used for multi-class classification. So first, we load the data set and separate the input features and target labels. Here, the data set contains handwritten digit images. So I load the data set uh, using load digits, and here X contains the image feature and Y contains the digit labels uh, from 0 to 9. Now we have to standardize the input variables and split the data into training and testing. So standardization scales features so that they have mean 0 and standard deviation as 1. So this improves the neural network performance. Here we also split the data into training and testing sets to evaluate the model. So here I use the standard scaler to standardize the data. Then I here split the data into 80% of training and 20% of testing using train test script. So next we convert the input to the tensors. So PyTorch models require data in tensor format for computation. So here I convert the training and testing data into PyTorch tensors using the float tensor and long tensor. By this, they have been converted to PyTorch tensors. Next, defining the MLP model. So, a multi-layer perceptron model consists of multiple layers: input layer, hidden layer, output layer. Activation functions like ReLU introduce a non-linearity. So, in that code, I define a neural network using nn.sequential with hidden layers of size 128, 64, 32, and 16. The final layer has 10 neurons for 10-digit classes. Next, we have to train the model by updating the weight, and we have to plot the graph. So for training the model, training involves forward pass, loss calculation, back propagation, and weight update. So the goal is to minimize the error over iteration. So in the code, I run for multiple efforts. In each iteration, I compute prediction, calculate loss, perform back propagation, and update the weights. I also store loss values to track training and progress. That's how these epoch values are calculated. So now to plot the training curve, uh, the uh, the graph is plotted between uh, training error and iteration using a matplotlib. Now we have to test the model, and uh, we have to analyze the performance of the model using accuracy, precision, recall, and F1 score. So after the training, we evaluate the model using the test data. We use the metrics like accuracy, confusion, matrix, and calculation report. So in this code, I switch the model to evaluation node and predict the output. Then I calculate accuracy, confusion matrix, precision, recall, and F1 score. So this is how the values have been calculated. And in this experiment, I have successfully implemented a multi-layer perceptron model for digit classification and evaluated its performance. Thank you.